You know, AI is absolutely everywhere now. It's in our cars, it's helping doctors, it's really changing the world. But as we're building this incredible future, we're also opening up a brand new, kind of invisible frontier for cyber attacks. We're not just talking about securing normal software anymore. We're talking about securing the actual intelligence that's starting to run our world. So let's pull back the curtain and see where the real dangers are hiding.
I mean, really think about that for a second. The AI models you download, the data they learn from, the very tools you use to build them, what if they've been secretly compromised? What if that helpful AI is actually a Trojan horse, just sitting there waiting for the right moment to cause some real damage?
So in this explainer, we're going to follow the entire life of a machine learning model from start to finish to see exactly where things can go wrong. We'll look at its hidden attack surface, how its data can be poisoned, and how the supply chain itself can be turned into a weapon. Then, we'll see what happens when it's attacked out in the wild, and finally, we'll talk about the new kind of security mindset we all need to adopt.
So what makes securing AI so different from, say, securing a website? Well, it's because the vulnerabilities aren't just in the code you or I might write. They're literally woven into the data, the dependencies, and the model's logic itself. This creates a whole new type of attack surface that most people aren't even thinking about yet.
Okay, this life cycle right here, this is going to be our roadmap for this whole discussion. It all starts with collecting raw data. Then you move into this pre-processing and training phase, which is where the model actually learns. And finally, you get to the deployed model, the one that's out there interacting with real people. And believe me, as we're about to see, every single one of these stages is a potential battleground.
And here's where the very first crack starts to appear: the handoff. You've got data scientists who are laser-focused on making the model accurate and performant. Then, they toss it over the wall to deployment engineers who are worried about keeping it online and making it scale. But who's looking out for the unique security threats to the AI itself? Well, a Microsoft survey of 28 companies found that a staggering 22 of them did basically nothing to secure their ML systems. That's the exact kind of blind spot that attackers just love to find.
All right, let's jump back to the very beginning of that life cycle we just saw, the data. It's simple, right? An AI model is only as good or as trustworthy as the data it's trained on. So what happens when someone intentionally corrupts that data?
Well, it's called training data poisoning. And this isn't just about feeding the model some junk information. Oh no, it's much more surgical than that. It's about strategically injecting malicious data to make the AI mess up on command. It's basically like programming a secret vulnerability right into the model's brain.
And this is the part that's truly terrifying. You don't need to poison a ton of data to do this. Researchers showed that you only need to manipulate as little as 1/10 of 1%, 0.1% of a model's pre-training data to create a working backdoor. It's like a tiny drop of poison that contaminates the entire well.
And this isn't just a theory. We have seen this play out in the real world, very publicly. Remember Microsoft's Tay chatbot? It was designed to learn from talking to people on Twitter. Well, within just 16 hours, users figured this out and just bombarded it with toxic, offensive content. They were poisoning its training data in real time. Tay quickly became this horrible mouthpiece for hate speech, and Microsoft had no choice but to pull the plug. It was a huge, dramatic lesson in just how vulnerable these open learning systems really are.
Okay, so we know the data is a huge risk, but what about all the tools and code you use to build the model? The modern ML pipeline is built on this mountain of open source software, and every single one of those dependencies is another potential door for an attacker to walk through.
And here's a simple but really dangerous fact that's easy to forget. Models are not just data. They are executable code. That's right. Many popular formats can run commands just by being loaded. This means an attacker doesn't even need to find a bug in your application. They can just hide their malicious code right inside the model file itself. The model becomes the payload.
And the scale of this problem is just staggering. Look at this. A simple Python project might pull in, 14 other pieces of code? But a pretty standard ML project using a popular library like transformers, it can pull in over 300 dependencies. That's more than 20 times the attack surface, 20 times the number of potential weak links in your supply chain. It's huge.
And again, these are not just what-if scenarios. A recent real-world attack started with a popular tool on GitHub. An attacker found a way to gain access, and then they did something clever. They pointed all the version tags to their own malicious code. This code didn't do anything fancy. It just scanned for secret keys during the build process and printed them out into the public logs for anyone to see. And with those stolen keys, they then compromised an even bigger project, causing this cascading failure that spread across the open source world.
All right, let's fast forward to the final stage. The model is built, we've tried to secure it, and now it's deployed. It's live. The fight now moves to the front lines, where attackers can poke and prod it directly.
So once a model's out there, attackers have a few main goals. They can try to steal it, basically rebuilding your secret sauce just by asking it enough questions. They can try to evade it by designing inputs that trick it into making a mistake. They can try to modify it with poisoning, causing those very specific failures we talked about, like a self-driving car suddenly ignoring a red light. And if they can somehow get you to run their malicious model, they can try to break out of its little sandbox and move through your network.
So what separates these two threats? It really comes down to the attacker's goal. With model theft, the prize is the model itself. It's your intellectual property, your secret recipe. A competitor could just steal all your hard work. But with model evasion, the goal is just to fool the model in one specific moment, like tricking a spam filter or bypassing a security camera. You could say it's the difference between stealing the entire cookbook versus just sneaking one bad ingredient past the chef.
Okay, we have definitely seen a lot of scary problems. So what on earth do we do about them? Well, it takes a whole new security mindset. It takes a defense in-depth strategy that protects the entire ML lifecycle, from that very first byte of data all the way to the final answer the model gives.
This little cheat sheet is a great way to think about it. It breaks down the threats into 4 categories: stealing, poisoning, inference, and invasion. And notice how the risks change depending on where you are in the lifecycle. See, when you're dealing with training data, the big worries are poisoning and stealing. But once that model is deployed and live, suddenly evasion attacks become a huge concern. You've got to be defending against the right threat at the right time. So, what are the actual, practical steps you can take? Well, to stop those supply chain attacks, you have to pin your dependencies to specific unchangeable commit hashes, not to version tags that an attacker can move. You need to protect your secret keys using secure tools. You have to enforce multi-factor authentication for absolutely everyone. Constantly audit who has permission to write code, and finally, you need to be monitoring your build pipelines for any weird behavior. These are the basic, foundational steps to hardening the whole process.
And that really brings us to the final big question. AI isn't just some cool tech experiment anymore. It's rapidly becoming critical infrastructure. It's getting baked into our power grids, our financial markets, our healthcare systems. So if we don't fundamentally change how we think about securing it, if we keep ignoring these deep systemic risks in the data and the supply chain, what are we actually building our future on? It's a question we all need to start answering, and we need to do it fast.